All right, let's talk about a huge challenge in the blockchain world. These systems are built on being totally transparent. Every single transaction is out there on a public ledger for anyone to see. But what happens when you actually need some privacy? How do you make a transaction without telling the entire world about it?
And that's the big paradox, isn't it? How do you build something confidential on a system that's designed to be completely public? I mean, it sounds impossible, but what if? What if there was a way to prove a transaction is totally valid without revealing who sent the money, who got it, or even how much it was? Well, a new system called Harpo says it has cracked the code. So over the next few minutes, that's what we're going to do. We're going to open up this black box together and see exactly how it pulls off this magic trick of verifiable privacy, one piece at a time. To really get what Harpo is doing, we've got to start with the foundation. It actually borrows a core idea from Bitcoin, but then it adds a crucial privacy twist. The whole thing starts with a concept called a UTXO. So UTXOs stands for unspent transaction output, and it completely changes how we think about a balance. Instead of just having one number in an account, with UTXOs, every single piece of value is its own unique thing, kind of like a digital receipt or an individual banknote. Yeah, so forget looking at an account and just seeing a balance of like $100. In the UTXO model, your digital wallet would literally be full of individual notes, maybe one for $50, a few for $10, and a bunch of others. This small change is actually the very first key to making transactions much harder to trace. Okay, so we have these individual digital notes, which is a great first step. But there's a problem. Right now, they're still just sitting out in the open on the blockchain. So the next big challenge is building a secret vault to hide them in. And Harpo does this with a really clever data structure called a Merkle Tree. Now here's the trick. Instead of putting the notes themselves on the public ledger, Harpo uses something called a cryptographic commitment for each one. You can think of a commitment as a locked box. You can prove your note is inside the box, but you never have to open it. And by organizing all these locked boxes into a Merkle tree, Harpo can prove that all the notes are accounted for without revealing any of the details. This creates a kind of perfect camouflage. The vault itself, the Merkle tree, is public, so everyone can see it. But the contents, our individual notes, are totally hidden inside their little cryptographic boxes. And this is the key. We can mathematically prove our specific note is inside that vault without ever having to show it to the world. Okay, but wait a second. This privacy creates a brand new, massive problem. If nobody can see which note is being spent, what's to stop someone from just spending the same hidden note over and over and over again? This is what we call double spending, and it would completely destroy the system. Harpo's solution? A clever little anti-fraud stamp. This stamp is called a nullifier. Every single time a UTXO is spent, a unique nullifier that's linked to it gets published on the public ledger. You can think of it as a one-time use token that basically just voids the original note. And here's the really genius part. It's like an invisible used stamp. The public ledger shows that a note has been used up by revealing its unique nullifier. But thanks to some crypto magic, no one can link that public stamp back to the specific note it came from inside the vault. So your privacy is safe, but fraud is completely impossible. Okay, so let's recap. We have our individual notes, the secret vault, and the anti-fraud stamp. But how do we tie this all together? How do you prove that you're following all the rules without revealing any of your secrets? Well, this is where the real magic happens. It's called a zero-knowledge proof. It sounds like something right out of a sci-fi movie, doesn't it? Proving you know a secret without ever revealing the secret itself. This concept is pretty much the cornerstone of modern cryptography, and it's what makes a system like Harpo even possible. To really get a feel for it, let's walk through an analogy. So first, just imagine a vault that needs a secret password to open. You want to prove to me that you know the password, but you're not about to tell me what it is. So you go into the vault room all by yourself, you use the password, and you come back out holding a unique object that I know for a fact could only be found inside that vault. So think about what just happened. I never saw your password. I have literally zero knowledge of it. But the fact that you're holding that object is undeniable proof that you must have known the secret to get in. And that, right there, is the whole idea behind a zero-knowledge proof. Here's one more quick one. Imagine you know the secret path through a crazy complex maze. To prove it to me, I challenge you over and over. I pick a random entrance and say, okay, come out through this exit. And you do it, every single time. After a while, I become mathematically certain that you know the path, even though I still have zero knowledge of the route itself. You've proven your knowledge without revealing it. So, let's bring it all back home. How does this magic of zero-knowledge proofs actually connect back to all of Harpo's building blocks? Well, this is how Harpo provides privacy that is mathematically provable. This is where it all comes together. With a single zero-knowledge proof, a user can prove everything all at once. That proof mathematically confirms, hey, the note I'm spending is a real one inside the Merkle Tree. I own the secret key to it. Its nullifier proves it's never been spent before. And finally, the transaction is balanced, so no money is being created out of thin air. It proves all the rules were followed. And the best part? The system can verify that single proof without learning anything else. Not the amount, not who sent it, not who received it, nothing. Every rule is followed, every transaction is valid, but all the sensitive details stay completely private. That is what verifiable privacy is all about. It's a really powerful idea. This technology allows us to completely separate the act of verification from the need to reveal our data. And that leaves us with a pretty fascinating question to think about. If we can apply this to money and assets, what other areas of our digital lives, like our identity, our credentials, or ownership, could be totally transformed by this power of proving without showing? Thanks for digging into this with me.